Hey everyone, welcome back to my math channel where I will be doing math videos. Today is the beginning of my non-calculus related videos, and I've been meaning to do this for a while, but I just felt that now was an appropriate time to begin. And I feel like the first topic that I really should introduce are functions. So what is a function? A function is any type of equation or relation such that each x value that's involved only has one y value attached to it. So instead of thinking of it as x and y, you can think of it as an input and an output. So say for example, you're at a restaurant and you want to buy a cheeseburger. Say one cheeseburger costs $3. If you were to pay $3, that's your input, and then you would get one cheeseburger back. If you were to pay $6, that's an input and you'd get two cheeseburgers back. But if you were to pay $3, they're not going to give you two cheeseburgers back because that means for one input you get multiple outputs. So that's just one example of functions. But we'll go a little bit more in depth on what functions actually are and how you can recognize them in tables and maps and graphs. So essentially, if you have multiple input values and multiple output values, and then each input is randomly matched to one output, then it shouldn't be too difficult to determine any function. So say for our input, we'll pick 5 random values, and we'll do 2, 3, 5, 7, and 11. And I did not intend for that to be a pattern actually. And for our outputs, we'll do -3, 6, 9, 14, and 23. So now if we were to draw arrows from one x value to some y value, or from one input to an output, this means that it's a one-to-one relationship because each x value, each input only points to one output. No two inputs point to the same output, and this follows our definition for a function, as each input being involved only gives one output. You don't get multiple outputs for an input in a function. And this follows that. However, if I were to change this 11 and make 11 go to an output of 14, that still works as a function because although multiple inputs go to the same output, it's still one output per input because 11 only has one output, 7 only has one output, 5 only has one output, and those two types of relations are functions. So the first one we saw is 1 to 1, which means that every input, we'll just say A, B, C, has one output, 1, 2, and 3, and they're all different outputs. Many to 1 is also a function because even though many different inputs lead to the same output, each input will only point to one. So say for example, in something like this, both A and B can point to 1 and C might point to 3. That's still a function because A points to 1 and only 1, B points to 1 and only 1, C points to 3 and only 1. So those are examples of functions, and it's just a matter of seeing where these arrows actually point to, and I'll get to how they work with tables and graphs in just a little bit. But that's only one to one and many to one. There are still two more, which are one to many and many to many. And those two are not functions. So these two are functions. And I'll just shorten that. But if you have one x value pointing to multiple y values, for example, if you have 2 pointing to both 14 and -3, that's not a function because each x value or each input can only have one output. In this case, your one input has two different outputs. And that works back in the cheeseburger example because you got two burgers for the input price of one burger. Or you could think of it as you got a burger and a slice of pizza for the input price of one burger. That doesn't work. And that means it's not a function. And we call this type of relationship one to many. So say for example, you have 3 pointing to 23 and 6 and 5 pointing to 9. That's one to many. So you have A, B, C, 1, 2, 3. Say A points to 1, 2, and 3. That's not a function. And many to many is just a combination of many to one and one to many. So it seems a little bit more chaotic, but it's still not a function, regardless. Say you have A, B, C, 1, 2, 3. We'll stay consistent with the examples. Say you have A pointing to both 1 and 2, and C also pointing to 2. This part seems like a many to one, but this seems like a one to many. So essentially, it's a combination of both. But either way, these two are not functions. So now we'll get to how to determine if any relations of functions based on the graph. So the essential idea is, say I have any type of graph, and we'll just draw something. It can be as very crazy, but it works for the purpose of this example. If I can draw a vertical line anywhere through this graph and it intersects more than once, it's not a function. Say for example, in this case, I drew a vertical line over here, and a vertical line's equation is x is equal to some constant c. So if I were to draw that and I get intersections, more than one intersection, in this case I got 3, 1, 2, and 3. It's not a function. And it doesn't matter, even if you draw 100 lines that only give you one intersection. So I could draw lines here, 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 there, and like this. I only get one intersection in all of these cases. But as soon as you get some vertical line that intersects more than once, it's not a function. So for it to be not a function, it means any vertical line, and I mean any because that's very important, intersects, like in case you're not aware, it just means it meets the graph, they kind of have the same value at this, they have the same y value at the same x value. It's like they meet, basically, the graph more than once. So if it intersects the graph once for all possible values of x, that's fine. But if it intersects more than once, that's not a function. If it doesn't intersect at all at certain points, that is something that you'll see in more advanced algebra. So this type of test is called the vertical line test, and it's a pretty fitting name for a very important test. The name literally describes everything, so I'm not really going into why it's called a vertical line test, but yeah. So that's how you would find out if any graph is a function. But if you have a table of values, then you need to check you would need to check the x values. So say, for example, you have 1, 2, 3, 4, 5, 6, 7. And then you have 2, 4, 6, 8, 10, 12, and 14. And I apologize for my table. So in this case, you would treat this the same way as you would with one of those maps above. It doesn't work differently. So in this case, 1 corresponds, it goes to 2. Like, if x is 1, that means y is 2. If x is 2, that means y is 4. If x is 3, that means y is 6. This seems like a one-to-one. So it's a function. But say, for example, if I were to change the 7 to a 1, I suddenly see two different occurrences of 1 in my x table. That means it's one to many because there are two of the same x, so it's basically 1, but they have two different y values. So it's almost like 1 goes to 2 and 1 also goes to 14. So that means it's not a function. So the moment you see the moment you see two of the same number in the x column, make check the y value immediately. If they're different, it's not a function. So this check x column for two of the same value. And then if y values are different, so if they're not the same, it means it's not a function. And I'm just using x and y, but if it helps, think of x as your input and y as your output. So x equals input, y equals output. And there's another way to think of it. Instead of writing y for all of your output graphs, sometimes if it's a function, some people write f of x, meaning that it's a function of some input x. And this is often used, like, you can either use this or you can use y. At least for now, they kind of mean the same thing. Y you can use if it's not a function, but f of x means your relationship has to be either one-to-one or many-to-one. So this must be one or many-to-one. And for it to be one-to-one or many-to-one, it has to pass the vertical line test. So bottom line is that for any relationship to be a function, any relation to be a function, each x value must correspond to one and not more than one y value. Each x value involved, that is. If there's a specific x value that doesn't have a y value, that's for more advanced math, and that will lead into something called asymptotes, but that's not important at this stage. It might be later on though. So to keep it concise and not like go on irrelevant tangents too much, every x value involved has to have one y value. Every input has only one output. Multiple inputs can have the same output, and that's still a function. But one input can't have multiple outputs. That's not a function. And graphically speaking, if you're looking at the graph, you have to be able to draw a vertical line everywhere, and if it only intersects once, it's a function. Or if you draw a vertical line anywhere and it intersects more than once, it's not a function. Thank you so much for watching this video, and I apologize for the length of it. It's a kind of important topic, so I talked a little bit more on this one than I normally would, but like normal, please drop any feedback and just keep practicing your math.